Statistics is the analysis of a collection of data. Here we have a table showing the number of goals scored by an under-15 soccer team in their last 20 games. We know that if we want to learn more about a scenario, for example, how this team is performing overall, we need to analyse the information that we have collected. So it's useful for us to know the middle or average number of goals scored, and this is known as the central score. And we usually find this by finding either the mean, the median, or the mode of the data. It's also useful for us to know the range of goals scored. Sometimes it's helpful too if we know if there are any games where the team performed really well or very poorly, and these are known as outliers. But in this particular example, you can see that the goals scored are all fairly clustered together, and so there would be no outlying scores. These three things are generally easy to find if the data is written out in ascending order. But what do we do if it's not? Here the information is in a frequency distribution table. Now, because there's only 20 scores, we could pretty easily write them out in ascending order. But imagine if they recorded the information for over 100 games, or maybe 500 games, and then entered it into this table. Writing that out in ascending order would be time-consuming, messy, and would make it increasingly likely that you would make a mistake in your calculations. So how do we find them without deconstructing the table? In the first part of this lesson, we will look at the two simplest calculations, the range and the mode. In parts 2 and 3, we'll investigate the more challenging calculations to find the mean and then the median scores. So let's start with the easiest one first. The range is the highest score minus the lowest score. Now these are pretty easy to see straight from our table. The different scores that we collected are listed here in this first column, as the information we were collecting were the number of goals that were scored in every soccer match. So we can pretty easily see that our highest score that we collected was 5, and our lowest score that we collected was 0. So taking the difference between these two, 5 minus 0, gives us a range of 5. The next easiest one to find is the mode, which we know is the score that occurs the most. And in this example, this means the most common number of goals scored by this team. Now in a frequency distribution table, as we mentioned before, the data that we are collecting is always written in this first column. So if they scored 0 goals in a game, if they scored only 1 goal in a game, 2 goals in a game, and so on. The number of times that this happened, or the frequency, is always written in this second column. So this team scored 0 goals in 2 of their matches. They scored 1 goal in 4 of their matches, 2 goals in another 4 of their matches, and so on. It's pretty easy to see then that the mode will be the score with the highest frequency. And so looking at this table, if we identify the highest frequency and match it back to its score, we'll identify the mode. So looking for the highest frequency, which is here at 5, and matching it back to its score, we can identify very clearly that the mode of this data set is 3. The mean is the average number of scores. And this means that I need to add together all of my scores and divide by the total number of scores that have been collected. This is trickier to do when the data is written in a table. We can see straight away that we collected 20 scores in total for the 20 games that the team played. And so to find the average, we need to find the sum of all the scores and divide that by 20. But how do we add together all of the scores without writing them all out in ascending order first? If I do start to write them out in ascending order, I can see from the table I have 2 zeros, I have 4 1s, I have 4 2s, 5 3s, 2 4s, and 3 5s. And if I start to add all of those together, I'd have 0 plus 0 plus 1 plus 1 and so on. Adding everything together gives me a total of 50. And so now I know the sum of all my scores. And to find the average, I divide that number by 20. But this is a pretty slow way of doing it. But we are just adding the same numbers over and over again, and we know that there is a faster way to do this. We could just multiply the scores together by the number of times that they occurred, or their frequency. So in that case, I would have 0 times 2, I'd have 1 times 4, I'd have 2 times 4, 3 times 5, 4 times 2, and 5 times 3. You can also see that I've added an extra column to my frequency distribution table and I've called it fx. So what does fx mean? Well, in a frequency distribution table, the scores column is usually called x and the frequency column is usually called f. And we know that in algebra, putting two letters together tells us to multiply them. So fx means to multiply together our f column and our x column. So let's do that. You can see that it's going to match up with the multiplications that we just performed at the bottom of the screen. So 0 times 2 gives me 0. 1 times 4 gives me 4. 2 times 4, 8. 3 times 5, 15. 4 times 2, 8. 5 times 3, 15. If I add all of these answers together, I get 50, which matches up with the sum of all my scores. So the fx column gives me space to add all of my scores together in a much neater, faster way than writing all of my scores out in ascending order. This means that the fast way to find the mean from a frequency distribution table is to divide the total of your fx column by the total of your frequency column. 50 divided by 20 gives me 2.5. And lastly, the median is the number in the middle of the data when it's arranged in ascending order. Again, I don't want to write all of my scores out to find it, but because we had them written on the last slide, let's just quickly check what our median should be by finding the number that does sit in the middle of the scores. So looking at the numbers written in ascending order, we can see that the median should occur between 2 and 3, and the average of those gives us a median of 2.5. But how do we find it in the table? Now we know we had 20 scores in total, and finding half of 20 is pretty easy. We get 10. We know this isn't the middle score as our answer should be 2.5, but what does this 10 tell us? Well, by halving the total number of scores that I have, I'm splitting my data into two groups. The first 10 scores occurring here, and the second 10 scores occurring here. So that 10 gives me my halfway point. Now because I had an even number of scores, everything splits into two groups perfectly, and there are no scores left over in the middle. So where would the middle number be? Well, it would be in the middle of these two groups. So between the 10th score and the 11th score. If we can find the 10th and 11th scores in the table, then we can easily find the number that should sit halfway between them. You can see that I've added a new column to my table called CF, and this stands for cumulative frequency. The word cumulative means to continually add. So this column will show us how many scores we've collected at each row in our table. Now here are the first two scores that we collected. They were both zeros. So currently we have 2 scores. Then we collected all the ones together and added another 4 frequencies onto that. In total we now have 6 scores. By row 3 we've added another 4 scores into that, which were all 2s. And so our total for the cumulative frequency is now 10. So here is our 10th score. Obviously the 11th score then has to occur in the next row. So looking at that, what's the median number then? Well, if the 10th score was 2 and the 11th score was 3, and the median is halfway between these two, then you can very clearly see the median should be 2.5. What do you think would happen if you had an odd number of scores? Let's say the total frequency was 21. How do you think you'd find the median then? Maybe that's something for you to think about.